Hi everybody, this is Mrs. Lehman from Math with Mrs. Lehman, and if you are watching this and you are one of my students, I would like to say to you, you did an excellent job today. You really went above and beyond, so nice job to you. Tomorrow we are doing day 2, and day 2 is a little different. Usually it's a little more challenging because you have some multiple steps going on in the questions. So I wanted to go over some of the predictions I have. I don't know what will be on anything, but based on previous years, I'm predicting that we're going to see a question where you have to write an expression based off of a ratio table, maybe plot the points from that expression, or I'm sorry, plot points from that data, or maybe write an expression and use that expression to solve for something else. I think we're going to see some geometry. I think we're going to see some coordinate plane stuff where you graph and then maybe find the perimeter or area of something, maybe a trapezoid, I would guess. I have no idea. And then I'm predicting that you'll see a greatest common factor question. I also think that order of operations is something that is asked quite frequently on day 2. Usually involving fractions. So the nice thing is, if you don't love fractions, but you know how to follow the order of operations, you can definitely use a calculator as long as you go step by step. All right, but anyway, what I'm going to do is go through some questions. I believe these were from 2015. No, we just went over those. I'm not quite sure which year these are from, but they're a little bit older. But some of these are challenging. You know, some years have definitely been more difficult than others. This set of questions, I feel like, was a definite challenge. So if you could pay attention, watch this, you definitely will be a little bit more prepared for whatever it is we have coming tomorrow. The coordinate grid below represents a town. Curtis's house is at -4, -6, and Jean's house is at -4, 3. Plot the points where Curtis's house and Jean's house are located. So the first skill you need to have to do this question correctly is plot the points. All right, so I already did this. I plotted the points, and then you would just need to figure out what is the distance between here and here. And again, you could just count the jumps. You could use absolute value and say, okay, this is 3 units up, this is 6 units down, and all together, you know, 3 plus 6 is a total distance of 9 units. Okay, so we know that, what were their names? Curtis and Jean are 9 miles away from each other because it says down here, each unit on the grid represents 1 mile. If Curtis can ride his bike at a constant rate of 12 miles per hour, how many minutes would it take Curtis to ride from his house to Jean's house? So you have to start first of all with that first part of the problem. You know that he has to travel 9 miles, right? And we know that he can go, we're going to start with what we know. He can go 12 miles per hour, and that means for every 1 hour. And we want to figure out how many hours that could scale up to. Now, one thing that we've talked about in class and something you should be aware of is that it may not, you know, in this case they gave you miles per hour and they want to figure out how many minutes. So we could change 1 hour to 60 minutes, right? So essentially we're figuring out how do we get from this side to this side, right? Well, if you can't divide or multiply, you need to simplify. That's the saying that we've talked about. So 12 doesn't divide to give you 9 cleanly, so we need to simplify this. And we know that it's 1/5 when you simplify that. So 1 times 9 is 9, and 5 times 9 is 45. So you have to figure out, first of all, that it's 45 minutes. And actually, that's all the problem is, figuring out 45 minutes, okay? But it looks challenging. You just got to write your answer on the line, show all of your work. Alrighty, the next question that we have here has 3 different expressions, and these all involve order of operations. So the use of PEMDAS, please excuse my dear Aunt Sally, however you want to think of it, and apply that to these problems. So first thing we have is 20 squared minus 18 squared. So 20 squared minus 18 squared. So we know 20 squared is 400 minus 18 squared. And remember, do one step at a time. So 18 squared, let me pull up my calculator. Maybe. I'm going to pause this. And poof, it's here. Okay, so anyway, 20 squared means 20 times 20, which we already said was 400. Now we're going to clear that out and do 18 times 18. Now, you guys have a scientific calculator that you can use, which is really nice because you can use the caret button to input any exponents. So remember, that looks like a little upward arrow type thing on the calculator. So anyway, 18 times 18 is 324. So you will do this, 324. So 400 minus 324. All right, so then you just have subtraction. Again, you're really lucky that tomorrow you have a calculator. Now, with that being said, the numbers are a little bit bigger usually than what you deal with on day one. So 76 is what that is. And the smart board doesn't want to write that. There we go. So 76. So the question is, which of these expressions have the same value as 12 squared? All right, so maybe I didn't mention that. Which expression or expressions have the same value as 12 squared? So 12 squared equals 144, because that means 12 times 12. Okay, so does expression A equal 144? No, that equaled 76. So that's not our answer. Let's look at expression B. Okay, so expression B, I'll do this in red ink. 8 times the quantity 4 squared plus 2 to the 4th power. So again, we just need to know what all of these things mean. So first of all, we need to do parentheses, and in parentheses we have 4 squared, which means 4 times 4, which is 16. So we have 8 times 16 plus 2 to the 4th power. All right, 8 times 16 is not what we would do next. We would actually do this step next because we need to take care of exponents before we move on to multiplication. So 2 to the 4th power, that means 2 times 2 times 2 times 2, which is 16. All right, so we have 8 times 16 plus 16. So 8 times 16 128. 128 plus 16 is 144. So does that expression equal the same thing as 12 squared? Yes, it does, because they both can be evaluated to be 144. So choice B works. But a lot of kids, when this question was on the test, did not finish trying all of these because they found one that worked and they thought it was like multiple choice where, oh, you found one that worked, yeah, you'd move on with life. No, you had to still test C, and it's hopefully one that they did because that was the correct answer. So 15 squared, or I'm sorry, that also equaled 144. 15 squared minus 3 to the 4th power. So again, you can use a calculator for these. So 15 times 15 equals 225. So 225 minus 3 to the 4th power, that means 3 times 3 times 3 times 3, which is 81. When you subtract those, you are going to get 144. So choices B, or expressions, I should say, B and C both equal the same thing as 12 squared. Alrighty. So answer expressions A. Nope, not A. Sorry, misspoke. What's new? Expressions B and C. All right. Let's move on to the next one. What is the area in square centimeters of the trapezoid below? So again, a trapezoid has 2 parallel sides, and you can always, regardless of how that trapezoid is set up, you can always cut a trapezoid into 2 triangles. So here's one triangle. I'm going to label that triangle 1. And I'm going to find the area of that, and then I'm going to find the area of triangle 2. All right. When you cut it into 2 triangles, both triangles are going to have the same height, 6.4 centimeters. So again, this is 6.4 here. This is the same distance here. Okay, so you just need to show all the work. So area of triangle 1, base times height divided by 2 is our formula. You start there, then you plug in what you know. So the base of that one is 8.6 times the height, which is 6.4, divided by 2. Again, you get to use a calculator, which is lovely, but the rule is make sure you write down the numbers that you're going to be putting into the calculator. So I'm going to clear this out. 8.6 times 6.4 equals 55.04 over 2. So we still have to divide that by 2. So divided by 2 equals 27 52/100ths. All right, and that'd be centimeters squared for this one right here that I'm kind of shading in right now. Okay, so that's 1, triangle 1. All right, triangle 2, we have a base of 12.9 and a height of 6.4. So area equals base times height divided by 2. The base here is 12.9 times 6.4 divided by 2. And then you're going to do the multiplication and division, and then it's just a matter of adding the 2 areas. All right, so 12.9 times 6.4, 82 56/100ths over 2. All right, and that would be 41 28/100ths centimeters squared. So you still have one more step. All right, so the last step is to take these 2 areas and add them together. So, let me get this. Okay, so 10, carry the 1, that's 8, that's 8, and that's 6. So 68 8/10. So 68 8/10 square centimeters is the answer. So again, if you happen to see a trapezoid question, you can always cut a trapezoid into 2 triangles. Each of those triangles are going to have the same height, in this case 6.4, and you're looking for that to be perpendicular to the base. All right, so nothing too bad on that one. Let's go on to the next one. I'm not going to do this one on the video just because, I mean, I'll talk about it with you, but I'm not going to show you how to do it just because that coordinate plane is very difficult for me to see on my smart board right now. So it says a park planner is designing a dog park. He wants to use a metal fence to enclose a kennel at the dog park. The vertices, that's a fancy word for the corners of the fence, are shown below. The units on the coordinate plane are yards. So they give you all these points. Okay, I could kind of roughly draw it for you right here. But so point A is going to be in quadrant 1, 4, -4, let's say it's right there. Point B, so you'd label it. Point B, -4, -4. Okay, point C is -4, 3. Point D is 1, 3. And point E is 1, -1. And point F is, try to group this up, 4, -1. So right there. Okay, and then he's going to add a gate between these 2 points. So I'm going to draw the gate in blue right here. All right, but the rest of this is the dog. Did I plot E wrong? 1, -1, nope. 4, oh, what am I doing? It's been a long day, guys. All right, derp. It was all there. Okay, anyway, so this is the gate right here in blue, but the rest of this, you know, it's like pretty much you know, pretty normal shape, I guess. But we have to find the fence distance that we need, the total number of yards that will be needed for the kennel. But again, the trick of this question really isn't plotting the points, which I was doing without a coordinate plane, just saying. It is finding out the perimeter, but not including that side AF, because that's where the gate is. So something like that, plot your points in order, make sure you know the difference between perimeter and area. Make sure when you plot points you label them. There's really nothing terrible about that question, very doable. I hope you see something similar tomorrow. So let's move on to the next question and see what's in store for that. Oops. Oh, the next question is kind of fun. I'm guessing you will see a question like this. Maybe I'm wrong, but it's only happened a few times and I was mistaken. A farmer stacked hay bales. The length and width of each hay bale are shown below. So we know that it's 4 feet long and 1 1/3 feet wide, and it says then the volume of the hay bale is 10 2/3 cubic feet. The farmer stacked 8 hay bales on top of one another. That's another trick there. So you're going to find out how we're looking for this missing piece. This is a question, right? We're looking to figure out what is the height from here to here. Actually, it'd be from the bottom right to there. Okay, so what's the height? But the key thing, if you didn't read carefully, is that he or she's going to have 8 of these on top of each other. And then we want to figure out what is the height of the stacked hay bales. So common mistakes kids would make on this is they would just they know volume equals length times width times height, and then they'd just plug in the 3 numbers that they have and multiply and get it wrong. So let's say hypothetically they did get it correct, the height, and then they left it like that instead of then multiplying that answer times 8, because again they're stacking these 8. You need 8 times that answer. So anyway, let's go ahead and solve this. All right, so first thing you're going to start with is a formula for volume. Volume of a rectangular prism is length times width times height. This is on your reference sheets as well. All right, and then you're going to plug in what you know. And actually, I'm not going to write V now because I know the volume right here is 10 2/3. So 10 2/3. The length I know is 4 feet. The width is 1 1/3 feet, and the height is our unknown. So this is not in the format we need to do operations with these fractions, so I'm going to do some converting to improper fractions. Now with a calculator, if you use the calculator does not mind doing all that work for you. So I'm going to show you how to do it by hand without a calculator, but we have scientific calculators with the fraction button, and remember on a calculator the fraction button looks like this, right? And each time you put in a new part of the fraction, you push that. So like you want to put in a whole number, you'd push the button for the whole number, and then you'd then hit the fraction button to say, hey, there's more. And then when you get to the point where you want to write the fraction line, that's where you'd hit the calculator button again. But anyway, so this is 30 2/3 equals, now I want to write 4 as a fraction, remember that's 4 over 1, times, and this would be 4/3 times h, right? So I'm going to try to simplify what I can here. When you multiply 4 times 4, you get 16. 1 times 3 is 3. So 16/3 h equals 30 2/3. Now, you need to be able to solve this equation. And if you're looking right here on your screen, you'll notice you have a multiplication equation. So to undo multiplication, you need to do the inverse, which is division. So how do we divide fractions? Well, we multiply by the reciprocal. So if I want to take 16/3 h and get rid of the 16/3, I need to multiply by 3/16, because that's going to simplify this all out, right? I have to do the same thing to both sides though. Right, so on this right hand side, that leaves me just with the height of the bale of hay, and then I have this that I need to simplify right here. So I'm going to work on that right now. All right, I like to simplify before I multiply, and that means you get to factor out anything that is common to numerators and denominators. So 3 and 3, if you simplified that, you'd get 1, right? So that'd be 1 and 1, which is fine. And then 16 and 32, 16 goes into 16 one time, it goes into 32 twice, right? So you get 2 over 1. So the height is 2, what unit? Feet. 2 feet. So a lot of kids stopped right there, but you know you have 8 bales of hay. So 8 times 2 is 16 feet high. All right, so the correct answer here is 16 feet. So on part 2, it's really multiple choice, or not multiple choice, wow, multiple steps. And, you know, you've got lots of little things to do. So not a ton of work, nothing difficult, but, you know, little baby steps to get there. Let's go to the next one. This one incorporates algebra. It says a square with one side length represented, a square with one side length represented by an expression is shown below. Right, here's the expression. It's a mix of algebra, right, and, you know, some numbers operations going on. It says use the properties of operations to write 3 different equivalent expressions to represent the lengths of the other 3 sides of the square. So one thing you know about squares is that all 4 sides are equal, and what they did is they gave you one expression, and you've got to find out an expression for this, an expression for this, and an expression for this that are all different but would have the same value. One of your expressions should contain only 2 terms. So this is also testing your knowledge of terms, which means you know, the same variables are in those problems. So the first thing I would do, if this were me approaching this problem, is I would take a look at this expression. 6 times the quantity 3x plus 8 plus 32 plus 12x. I would start by maybe just distributing this first part. Okay, so 6 times 3x is 18 copies of x, plus 6 times 8 is 48, oops, plus 32 plus 12x. All right, so that would work. There's all kinds of options here, but so 18x plus 48 plus 32 plus 12x. All right, in the next one, I'm going to combine like terms. All right, so actually no, I'll just combine the x's. All right, so I'm going to take, oh, please hold. Okay, I'm going to take right here, I could combine 18x and 12x. 18 plus 12 gives me 30. Whoa, that's a mess. Hold on. 30 x's plus 48 plus 32. All right, so that could be another side, but I've got 3 different sets of things going on there, and they want one where it's only 2. So 30x plus 48 plus 32 could work. All right, and if I finish simplifying this all the way, right, I could combine 48 and 32. So I could say 30x plus 60. No, that's not right. 70. Derp. It's been a really long day. All right, so did I say 70? It's 80. Oh my goodness. Mrs. Lehman, go take a nap. All right, so 30x plus 80. Yikes. All right, 30x plus 80 would be the one that they're referring to with just 2 terms. There's nothing that we can combine there that's already in simplest form. So anyway, that would work. Not a great question. I don't love that, but they love equivalent expression questions, so they just found a way to incorporate how to ask it with a little geometry involved. This next question says a carpenter built 3 bookcases, A, B, and C, to stand next to each other along a wall. The total length of the wall is 456 centimeters. The carpenter will build 2 more bookcases, D and E, along the same wall. These 2 bookcases will have equal widths. The widths of bookcases A, B, and C are shown in the table below. Okay? So, write and solve an equation to determine W, the greatest possible width for the bookcases D and E. So we know that all together, including D and E, can only be 456 centimeters. So that's really the key here. 456 centimeters. I'm going to write on the side because that is a pain at the bottom. All right, so 456, and we've got to pretty much include all of these. So that would be 132 plus 94 plus 108. I shouldn't really continue on the next line here, but I'm going to. Plus W plus W. So we're going to write that equation. Now we got to solve it. Well, not solve it, but simplify it before we solve it. So 456, we can combine like terms. So we could say equals 2 W's, right? So 2W plus, if you take 132, 94, and 108, we can add that. So that would be 14, that would be 13, so 334 would go right here. Okay, now we've got to solve for this. So you want to get the W by itself, so that means we got to get rid of this from each side. Okay, this is a 2-step equation. I don't know what I think of that in 6th grade, but regardless, you're going to get 122 here. So we know if 2 bookshelves have to make up a total distance of 122 centimeters, we know, there's a W, there's a W, you got to divide the 122 by 2. So 122 divided by 2, which would be 61. So write and solve an equation. So this is a 2-part thing. Here's the equation. All right, that would be worth 1 point. And then the greatest possible width would be 61 centimeters would be part 2. So even though they gave you only 1 line, they expect you to do 2 things. So that's kind of a key thing about part 2 questions. They ask you to do multiple things within the question, and they don't necessarily give you a line to write each of those things, so you've got to be careful to make sure you're answering all parts of the question. Kind of just a tricky thing that they do for day 2. Oh, wow. And there goes my planning period. Anyway, I'll continue. Oh, there's only 1, 2, 1, 2, 2 more questions to do. So I'm just going to pause this for a minute and I'll come right back and finish it. Bye. So this next question says Darnell's car used 8 gallons of gas to travel 340 miles. After a mechanic worked on the car, it used 7 gallons of gas to travel 350 miles. So you're going to essentially find his gas mileage. And then you're going to incorporate the price into that. It says if the price of gasoline was approximately $4 per gallon, how much less, to the nearest cent, per mile did it cost to run the car after the mechanic worked on it? So the first thing you need to do is figure out how many miles he can get on 1 gallon of gas. So at first, this was before getting it fixed, it was 340 miles for 8 gallons. All right, so again, you can use a calculator as long as you have it set up. If I can get the calculator to come up. So 340 divided by 8 equals 42.5 miles per gallon. All right, and then you have after he fixed it, which was 350 miles, and that took 7 gallons. And when you divide that, that means he's getting 50 miles per gallon. All right. Then, that's only one step of this. If the price of gas was $4 per gallon, how much less did it cost to run the car after the mechanic worked on it. So we want to figure out the price essentially to go a mile. So it's $4. So $4, and you're going to get 42.5. Let's see, miles. I want to figure out the price per mile. Okay, so that's why I'm doing that. So essentially what I'm doing here is it was $4 for 1 gallon, right? So on 1 gallon of gas, I can get 42.5 miles. So that's why I'm replacing that, 42.5 miles. Right there, let's go ahead and divide. That's going to give us a price per mile. So 4 divided by 42.5. That means it costs you, that's really terrible to see on mine. Let's see if I can see it on my computer screen better. $0.09. So it's going to cost him 9 cents to go 1 mile. So $0.09. All right, now this example, after he fixes it, it's going to cost still $4 per gallon, but on $4, he's going to be able to go 50 miles instead of only 42.5. So again, if you take your dollars and divide it by your miles, you're going to find the price per mile. Maybe if I can get this thing to work. All right, so, whoops, clear it out. $4 divided by 50 miles, that means each mile you drive is going to cost you 8 cents. So, that's 8 cents per mile. And the question asks us how much less to the nearest cent per mile did it cost to run the car after the mechanic worked on it. So 9 cents minus 8 cents means it cost him 1 cent less. All right, so anyway, kind of hurrying through this, but it's 1 cent. Oh, that smartboard is terrible. 1 cent per mile less than what it was before he fixed it. So again, a question like this, you're going to have to use your understanding of unit rate quite a bit. You have, quite a few steps here, but none of those steps in and of themselves are that difficult. It's just a few of them together. All right, and then the last question I'm going to go over for this video says the circus, maybe I'll join. The circus had 1 performance at the Dewey Civic Center and 1 at the Atlantic Auditorium. The Dewey Civic Center has 1,600 seats. Tickets for 85% of the total number of seats were sold. How many tickets were sold? So we know is over of, or part over whole, equals percent out of 100. Okay, we know that there is a total of 1,600 seats. So that's the whole number of seats. I'm going to put that on the bottom. So 1,600 goes here. I know that 1,600 represents 100% of the seats. And we know that tickets sold represent 85%. So the part we're looking for is how many tickets does that equal. So to get from 100 to 1,600, you got to multiply by 16. So I've got to take 85 and multiply it by 16. All right, and that's going to give you the total number of tickets. So, again, 85 times 16 equals 1,360. And I always say to make sure your answer makes sense. And if you're selling 85% of your tickets, 1,360 is pretty close to all of the seats, right? So that makes sense. There's another part of this. Lucky us. Atlantic Auditorium has 850 seats. Tickets were sold for 816 of the seats. For what percent of the seats were tickets sold? So again, you've got a part over whole question. We know the total number of seats is 850. We know that 816 were sold, right? And we want to figure out what percent were sold. So we're missing that. We know percents are out of 100. So one thing you can do that's really easy is focus on this side and just divide. So 816 divided by 850 will give you a decimal of 0.96, so 96 hundredths. And to change a decimal to a percent, you just move your decimal place twice, so that's 96%. Another way you could do that is you could try to find the connection from 850 to 100. So 850 divided by 100, divided by 100 equals 8.5. So I need to divide 816 by 8.5, and you're going to get the same thing. All right. I'm racing to beat announcements right now. So 816 divided by 8.5 equals 96%. So two different ways of getting to that same answer. But anyway, 96% of the seats sold. Thanks for watching again, guys. You guys did an excellent job today. You really worked very hard. Tomorrow's a little bit more of a marathon. There's multiple step questions that you have to do. So please persevere. You guys will do awesome again. Thanks for everything. Bye.